Welcome back, ladies and gentlemen, to our How to Make a 2D Sandbox Game in Unity series. So, in the last episode, what we did was, if I run this, should work. Yep, perfect. So, yep, we're picking right back where we left off last episode. In this episode, we're going to change these little white boxes to actual sprites. So, we got the sprites at the end of the last episode. But now we have to get these ready to actually be used. I think they automatically are, actually, interestingly enough. Let me just double check. So the thing we're doing now is just going to make sure the import settings are all good. As you can see, it's a bit blurry here, but that's kind of what we want, seeing these are vector graphics. If we're dealing with pixel art, so for example, we use the Minecraft texture packs, then you want to change this to point no filter and press apply. You'll see that it gets a bit more, the pixels are now more pronounced, but these are vector images, so we don't want it to look like this. We want it to be build near, or however you say that word. And yeah, so that just gives it a nicer, smoother look. But yeah, so that's that. We don't need this zip file here anymore. You can delete that. That's all good. And now we're just gonna open up our script again and get going from there. So the first thing we want to do, guys, is just create a few sprites here. So we've got the sprite tile. That's fine. What we want to do is just change this to be from sprite tile to maybe sprite stone. That's going to give us an error because we have to change this here as well, stone. Then you want to go back into Unity and just open up the object. So we want to put our stone sprite in here. So just click that little circle here, right there. We'll bring up this little window here, and from here you can choose whichever sprite you want. We're going to choose, where is it? Stone, boom, stone. So now, we just want to hit run. This should work. The terrain should be made out of stone, yes. But, as you can see, the sprites are too big for each cell. So why is that happening? We could just resize them in script, but that doesn't make much sense. Waste of time. It will be quicker for us to just go here into the tiles. Control A, select all of them. Pixels per unit. So the pixels per unit is how many pixels it is across the dimensions of the sprite. So as you can see, it's 128 by 128. So it shouldn't be 100 here. It should be 128. By 128. So you want this number to be the same number as pixels in the sprite. That way the sprite will automatically fit into the cells in Unity's interface. The grid is probably a better word. But yep, so that'll resize. And now if I drag this in, you can see that it perfectly fits into that little square there. So we can delete that. If I run again, this should look a bit better now. At least everything will be in the grid as it should be. There we go. And it looks like that seems to have worked. Yep. So that's pretty much that done. So now we're getting those generating stone. But we need grass, we need dirt, and even possibly some ores. So that's what we're going to do in this episode. So with dirt, we just want dirt to cover up a couple layers at the top of the terrain. So to do that, we want a couple of variables as well. So first off, let's have a public int dirt layer height equals, let's maybe give it 5. And then once we've done that, we also want a public sprite dirt and then a public sprite grass. So then we want to go down here, and in this loop, the for int y equals 0 in our generate terrain function. As you can see here, we're creating a new game object, giving it a name, and then all that. What I want to do is not name it here. I want to name it based off its sprite, and then same here. So that's fine there, but I want to say if y is less than height minus dirt layer height. Then do this. I want to say sprite, tile sprite equals stone. In fact, I want to move that up here before in the, that we put it in that if statement, and then I want to set the sprite to tile sprite down here. So sprite render dot sprite equals that, and then I want to say new tile dot transform dot name equals tile sprite dot name. So it will automatically equal the sprite's name, which will just make it easiest for us to see in the hierarchy to determine which sprite is what. But so if that is less than height minus dirt layer height, so it's going to be less than the height minus, in our case, 5, then it's going to give us a stone sprite. Is that right? Oh no. Here we go. Wait. You want to declare tile sprite, and then in the if statement here, you want to say tile sprite equals stone. That's what we were trying to do. There you go. And then you want to say else. And then in here, you want to say tile sprite equals dirt. But here's what's going to happen now. We're not going to get anything generating if it's above the dirt layer height. So there's not going to be any dirt generating. Because this is only going to generate if it's less than the dirt layer height. So what we're going to do is Control X, cut that from there, get rid of that empty line. After this if statement, you want to put that there. And now that should theoretically work. So let's give that a go. Save that, go back into Unity, let it compile. Oh, and the other thing we have to do, save in Unity as well, make sure you keep doing that. But we also have to set our dirt sprite and the grass sprite. And then you want to press play. And boom. So it seems to have worked. The places where it's not generating, I'd like to assume are caves. But to make our lives a bit easier, I might add a boolean, just so if the boolean is checked, generate caves. If it's not checked, then don't generate caves. So I'm going to do that right now. So right above here, public bool generate caves. And we'll say is true for now. And then down here, I want to say if generate caves, then do this. Otherwise, if it's not generating caves, we want to do this. So this is a bit mundane. I'm going to keep this like this for now. We'll test it, and then I might chuck that into a function of its own. And I'll show you guys how to do that as well. So right now we're saying generate caves. That's cool. It generates with caves. I uncheck it, play it again, and no caves. All right. So and we can see that our dirt layout is working properly as well. So that's all good and all. It's pretty seamless. Yep. So that's fine. Now I'm going to turn on generate caves again, and I'm going to put this into its own function. So underneath it all, I'm just going to say void create. I'll say place tile, because then we're going to also use this to do building. So we're going to use the same function. So this might actually have to be public as well. So yep, public place tile, and then do that. That's our function there. And the way I like to do functions, I just copy paste the code I'm going to put into the function. I'll cut it from there. Control V, paste. We're going to get a bunch of errors because these are not defined in this function's space. And I'll show you guys how to fix that. We will also want to get rid of this. And right here, I'm going to say place tile and that. There you go. And then same here, place tile. So now, how do we fix this? We're going to pass in a few parameters. So parameters in a function, they fit into these little brackets here. So the first parameter we need is the sprite to place. So the sprite we're placing is going to be called tile sprite. Our next parameter is going to be x. So x is a vector to float. So it's going to be float x, and then we also need y, which is going to be float y. And there you go. So now we're going to fix these errors because these now saying, hey, I need parameters to run this function, but you haven't given me any. So in here, we're just going to put tile sprite x, y. And we can just copy paste that into that. And that's going to just save us from writing this function every single time that we want to place a sprite. So now if we click somewhere, we can also place the sprite. Just by passing in x and y, we can pass in the mouse x and mouse y position so that we place a tile right where the mouse is. So that's fine, but we're not getting any grass on top. So how do we create grass? Right here, we're going to say else if y is less than height minus 1. And then place that, and then otherwise tile sprite equals grass. Now when we run this, we should get grass on top. There we go, with caves and everything. Perfect. How's it look in the game scene? Alright, we can't really see anything in the game scene, so what I'll do, show you guys a cool nifty little shortcut. You know, I'm going to zoom your camera in a bit, just so you want to see what you want to see in the game scene, essentially. Select your main camera, Control-Shift-F. And the camera is a bit too small. Right, orthographic is fine. We want to make this about 60. Too much, 30. Too much, 20. 20 looks about right. That way in the game scene now we're getting this. I'm going to turn on this, turn off this low resolution aspect ratios. That gives us gets rid of the border. I just find it a bit nicer to look at. And then also give this a background color. Something maybe, I'm not sure. That looks about fine for now. We can always change this later anyway. So that's just to give us something a little bit prettier to look at. Save that. Oh, exit play mode, then save that. I didn't save it, did I? That's alright. I'll do that again later. See, this is why you always got to make sure you exit play mode. But that's all good. So now, the next thing we might want to generate, we've got two options here. We can either go into some ores, or we could go into, that's a bit of an odd cave there, or we could go into some trees and all that. I might generate some trees first, because why not? It will give us a little bit more nicer looking terrain maybe. So to generate trees, we're going to need a couple of things. First, we're going to need sprites, obviously. So public sprite log, and then we'll say public sprite leaf. And then we also need a public, we'll go int tree chance. So the tree chance, what that's going to be is a number, which means 1 out of this number is the % chance for a tree to spawn. So for example, we have 1 out of 10 chance to spawn, which is a 10% chance. If I do this out of 100, that's a 1% chance of a tree to spawn. And that is for every block on the surface. So when we generate our grass and tiles here, once we're under the top layer, if we generate grass, that means this is the top layer of the terrain. So on the top layer of the terrain, we want to make a decision. We want to say tree chance equals random.range range between 0 and tree chance. No, this should be int. We'll get int t equals that, and then we'll say if t equals 1, then we want to generate a tree. So this is going to say generate a tree here. So how do we generate a tree? Oh, this should be there. There you go. So, yes, back to the question. How do we generate a tree? Well, we just have to say, give a image of a tree and say, place the blocks as we say. So I might put this in its own function just to keep this bit a bit cleaner. So above the place tile function, we want to say void generate tree, and we want to give it a float x and float y position. And then we're going to make use of this place tile function right now. So we want to say generate a tree. We want to place it at generate tree, place it at x, but we want to place it at y plus 1. Just so we're not placing on the grass terrain, we want to place it one block above the grass terrain. So in the generate tree function, now we want to say place tile, and this is why we made use of this tile. Easy, all we have to do is give it a sprite. So we're going to say log, where we're going to place it, x and y. Cool. So if I go back into Unity, save that, go back into Unity, head to the terrain, and we want to give this the sprites. So what I might do, I might just make use of this one for now, and then give it a leaf as well. So leaf is going to be this one. There we go. Tree chance at the moment is 10, which means we might get quite a lot of trees. And in which case we're getting, that looks about fine, to be honest. These trees are right next to each other. But yeah, so that's our first block of the tree done. To make our life easier, I could revert this back to use these tree side blocks, which I might do for now. If I head back in here, did I generate? Yes, it did. Okay. Okay, so I believe you guys can spot this as well, an obvious issue. Basically what's happened here is that the cave has said don't generate there, but our tree is still trying to generate there, which means we're going to get floating trees every once in a while, just like that. But so we might stick with using this sprite for now, and then once we get the trees generating, we can easily switch those out. Okay, so let's first fix this issue. How can we stop this generating? Easy, we're just going to say only generate a tree if the tree is standing on a block. So how do we check if it's standing on a block? We're going to have to do, we're going to use what's called a list. So to use a list, you first have to say using system.collections.generic. Basically, this is just importing that namespace into Unity to say, hey, I'm going to use a list. Please make sure that I can use it. And then we might put that here. We'll say public list of, let's say game objects. I kind of want to say, we'll say game objects. Public list of game objects, and these are going to be world tiles equals new list of game objects. Cool. But that list is going to stay empty if we don't add anything into it. And basically what we want to add to it is every time we generate a tile, we want to say world tiles dot add new tile. So new tile is our game object, which is that tile, and we just want to add it to our list. But we can't reference positions by this. So let's see. Let's change this to a vector 3 list. Vector 2 list, sorry. Vector 2 list. and that's going to give us an error down here. We want to say new tile dot transform dot position, right? The reason I did that is because now we can say if there is a instance in this list where the vector2 is say 0, 0, for example. So now I can say easily, I can say generate a tree if world tiles dot contains, that's going to search through the list, make sure that there is a object or vector2, which is going to be a new vector2, and it's going to have to be x and y. Boom, there we go. All right. So I'm thinking that might work, but it might not, seeing as we're generating caves afterwards. Let's give it a go. It's the only way to find out. If it doesn't work, we'll go do some fixing. So now we're not getting any trees. Fantastic. If world tiles that contains this new vector 3 x and y. So we're placing tiles down here. The tiles are being placed after we do this check, which means when we do this check, there technically is no tile there. So, how do we do this? What we'd want to do is maybe... Okay. So we want to generate caves to sort of say, generate... Okay, so first we have to generate caves. We have to do this if generate caves bit. So that has to go above here. Except tile sprite is not defined at the moment. Right, okay, no. I see what the issue is. Let's go back. Control Z. Alright, so back to here. That's all proper. This bit is wrong. So we're going to cut that there, and we're going to put that at the end here. We're going to say if y is equal to height. Is that right? Y less than height minus 1. Y is equal to height, then do this. There we go, and that should work. Did it work? We don't seem to have any trees. Any trees? No. Interesting. Are we getting any world tiles? Yes, we are. Okay, we have 3,350. Perfect. So that bit's working. Why isn't this bit not working? Y is less than... Y is greater than height minus 1. Sorry, this has to be equal to height minus 1. Because y will never equal height, seeing as we're only looping until while y is less than height. That's how we're doing the loop, which means we can do while y is less than or equal to height. It is viable, but I'll just keep that as it is for now. Did that work now? Still nothing. Interesting. I'll try it one more time just to make sure. Okay. Oh, what's going on? That might work. Any luck? No. Are these, does that do it? Yes, it is. Okay. Okay, then let's do what I said before. We'll add an equal sign there. Still nothing. Alright, so place tile if generate caves. Then if it's above the surface value, place a tile. Otherwise, if it's not above the surface, hold up. Hold up. Oh no, but that's generating its own tree, isn't it? Yeah. If y is less than, I believe the issue might be in this line. Let's comment that out and give it another go. Okay, so we're getting trees. Okay, so it is in that line, but we're still getting floating trees because, okay. So that line is going to fix our issue if we figure out how to write it properly. So just for our ease, I'm going to do it like that. If world tiles contains new vector 2, x, and y. So it's going to place a tile at x and y. And we'll generate a tree at y plus 1. Does it not contain that? What's our world tiles? Because the issue with using floating point numbers is they are very precise and sometimes they are inaccurate. But it looks like it is all correct. They're all on 0.5s. So basically this list contains the position of every block in our terrain. So realistically, if you have a really big terrain, you don't want to really open this because it might crash Unity, as we did in the last episode. But interestingly, we're still not getting any trees. Where are my trees at? It contains this. I'll say if it but if I say it doesn't contain, then if it contains there, it should contain it because we're adding it here. Okay. Get rid of that again. The world tiles that contains. Alright, so I might skip this bit and I'll get back with you guys once I've fixed the issue. Alright guys, so I think I found the solution. We're checking if it contains x and y. X and y are going to be either 0, 1, 2, 3, 4, 5, all the way up to world size and all the way up to height. But the thing we're adding into the list is its exact position, which is x and y plus 0.5. So I'm going to do it maybe this way. Rather than saying up here, where is it? Up here, rather than saying x minus 0.5, y minus 0.5, I'm going to put here minus vector 2 dot 1 times 0.5. This should be minus. There we go. Is that going to give us vector 3? Should be vector 2. But we'll do vector 3. I don't think it will give us too big of an issue, but we'll see. If it doesn't work, then we'll do it the other way. Trees. Yes, we're getting trees. Anything floating is the question? No. Okay, so there you go, guys. Debugging at its finest. Let's give it another generation. Anything floating? No. Alright, I think we seem to have cracked the code. I'm going to increase the tree chance so there's less trees. And, okay. That seems to be working fine. There we go. So now we just have to finish off what a tree looks like. And this is where we're going to define our tree. So here we're just going to say boom, boom, boom. Maybe 5 blocks high, so +1, +2, +3, and +4. So it's going to be 5 blocks high there. Let's see how high that is. Of course, I'm going to change that. Don't you worry, guys. I'm putting it into a loop. That's a definite thing to do. But so far, at least we're getting a poll of logs. That is fine. If I select it, yeah, okay, so all our naming is right as well. Just to double check. That's perfect. Okay, so now up here, I'm going to give this a break here. I'm going to say public int min tree size. I'll say maybe equals 3. So this is going to be, sorry, min tree height is probably a better name for it. How do you spell? There we go. And then, there we go, min tree. We want this to be max tree height, which I might do 6 maybe. I'll do between 4 and 7 might be too much. 6. Yeah. All right, we'll keep it like that for now. We can always change that in the inspector anyway, so that's fine. Where I'm going here, we want to say for int. Oh, sorry. We want to say int tree height equals random dot range between min tree height and max tree height, and then we want to say for int I equals 0, I less than tree height, less than equal to tree height, I plus plus, and we can get rid of these 4 lines because now we've condensed it into this line, and we're going to say y plus I. So it's going to y plus 0, y plus 1, all the way up to the tree height. So now we should get varying height of trees. And how's it looking? Are they varying heights? They look to be, yes, they are. There you go. Play around with the heights. I might leave it as this for now. It seems to work fine. But yeah, just change these values here. And let's clean up this inspector a little bit. What do you guys reckon? We're getting a whole bunch of numbers, whole bunch of just variables and things we can edit, and it's just a mess, just number after number. So if you guys haven't seen custom inspectors before, this is how they're done. Let's first organize this. So first we want to say in the square brackets, we want to create a header. And then in the round brackets, in normal brackets, parentheses, and speech marks, we want to put what we want to call that header. So for example, we might call this tile sprites. Cool. Save that, go back into Unity, and you'll see something pretty cool happen. If we go back here, tile sprites, boom, we get a nice little header there. Now we want to do that for the rest here. So for example, here I might put the header for trees. And then we might make this private for now because we don't need this taking up space in the inspector. We might leave this here, that's fine. Seeds and noise going to go together. Cave frequency is with that's with that. World size, cave surface value, generate caves, delay height. Okay, so this is going to be under the header of generation settings. And then have another header here under noise settings. There we go. And if we go back into Unity, save that. There we go. We get nice headings to just break up our inspector a little bit, just to make it easier for ourselves to understand. There's no other particular reason for that. And yeah, so now we're getting trees logs, but we're not having any leaves. So let's say generate log here, and then here we're going to say generate the leaves. So what we want to do is on top of our tree height, we want to add some leaves. So right here, generate leaves, we're going to say leaf, obviously, not log, leaf. Y is going to say y plus tree height. Plus, get rid of this bracket, equal sign. Put that again here, and then we'll say plus 1. And how high are normal Minecraft trees or that sort of style? We'll say maybe plus 2. Say that, give it a go. With only testing we can find out. So yep, so now the idea is to take these and put some there, and then put some here, and that's all going to be what our tree looks like. You can define a tree however you want to define a tree. You essentially place blocks however you want, using these sort of coordinates. So tree height is at the top of the logs. That's the very max height. And then you want to, by plussing 1 to, or by plussing any number to X and Y, you can give it a sort of nice style. So now I'm going to copy this bit, those two lines, and I'm going to say X minus 1, X minus 1, and then copy those two lines again, and you want to say X plus 1, X plus 1. Go back into Unity, hit play, and we should get trees. There we go. It seems to be working perfectly. There we go. Now we're getting nice little trees for our terrain. Look at that. Already in episode 2.